in Iraq, nowadays, we have no vector-borne disease problem rather than leishmaniasis. Malaria was endemic in Iraq since many decades, and we are in eradication phase for malaria nowadays. But we still suffering from leishmaniasis, both type, visceral type, which is called visceral leishmaniasis or Kala Azar, and cutaneous type, which is in Iraq called Baghdad boil, and in Syria, that place called Aleppo boil. So it is cutaneous leishmaniasis. Nowadays, there is outbreak of cutaneous leishmaniasis in most of Iraqi provinces. Our vector control strategy depend on integrated insect management, which is the usually we use indoor spray and spray of surface collection and the breeding site for mosquito with larvicidal insecticide, and also we use fogging, both type of fogging, thermal fogging and ultra ULV, ultra low volume spray type. So two type of spray. Also, with these activities, we have rodent control, because as you know, the rodent is one of the reservoir for leishmaniasis parasite. About the mosquito susceptibility test, the last susceptibility test we conducted in Iraq in 2009, and we end in 2010. Unfortunately, from 2010 till now, we not do another susceptibility test because the kits not available. Fortunately, someone promised to provide us with the kit from buyer. Inshallah. God willing. Okay, so introduction. I have nothing new in my introduction rather than what's said by Mr. Gerhard and Justin. The objective of this study is to determine the susceptibility or resistance of Anopheles and the Culex mosquito to commonly used insecticide in Iraq. The study conducted in 16 randomly selected villages from 14 out of 18 Iraqi provinces. 4 provinces excluded due security reason, and most of you hear about the security conditions in Iraq. So we include only 14 provinces. Mosquito collection. Mosquito were collected during the period from September 8, 2009 to November 18, 2010 from the 16 field site across the 14 selected provinces in Iraq. Manual, electrical aspiration, and CDC light trip were used for mosquito collection from indoor and outdoor location. All the collected mosquito was wild type. That is to say, it is not breeding in the lab from the outside, from the nature. Okay, all the collected mosquito are a wild type of unknown age and physiological status. Adult female mosquito were identified and pooled using Naval Medical Research Unit 3, or called number 3. This is located in Cairo, Egypt. Mosquito identification key, and after the test identification, the results are confirmed by molecular method PCR in Cairo number 3. Insecticide susceptibility test for mosquito, Culex pipinus, Anopheles silverbacter, and Anopheles volcanimus, and Anopheles stephensi. This type, in addition to Anopheles sarcovi, is the common type of Iraqi Anopheles. But sarcovi in one of the excluded provinces. In the start, we exclude four provinces, and sarcovi present in the excluded province because the habit of sarcovi, it is live in the high mountains in north of Iraq, in Kurdistan region. Okay. Were separated exposure to diagnostic doses of various insecticide for susceptibility test using insecticide impregnated paper as described by standard WHO testing protocol. The following insecticide were tested: deltamethrin 0.05%, permethrin 0.75%, lambda-cyhalothrin 0.05%, malathion 5%, and bendiocarb 0.1%. For each treatment, 4 test tubes were used. 1 untreated paper as a control, and 3 treated paper to expose the mosquito. An average of 20 to 25 mosquito was introduced in each tube. Female mosquito used in this study were exposed for 1 hour to insecticide treated paper and monitored at different time interval: 10 minutes, 20, 30, 40, 50, and 60 minutes to record the knockdown time. After 1 hour exposure, mosquito were transferred into holding tube for recovery and provided with cotton wool weighted with a 10% of honey solution. Mortalities were recorded after 24 hours, and the susceptibility status of the population was graded according to the WHO recommendation. Insecticide exposure took place in a room with a temperature of 25 plus minus 2 centigrade and 70 to 80% relative humidity. Data interpretation: the resistance status of the mosquito samples was determined according to the WHO criteria. Mortality rate more than 97%. This is the WHO criteria, nothing new. More than 97%, the population was considered fully susceptible. Mortality rate ranging between 80 and 97% resistance susceptibility in the population. Mortality rate less than 80, the population was considered resistant to the tested insecticide. Mortality rate were corrected using Abbott formula and control mortality above the 5%. Fortunately, we not need Abbott formula because the control mortality less than 5%. The result: a total of 8,180 female mosquitoes were used in the test, belongs to 4 species: Anopheles volcanimus 23%, Anopheles superbactus 18%, Anopheles stephensi 13%, Culex pipinus 46%, a total of 1,485, about 18.2 mosquitoes were exposed to lambda-cyhalothrin, 20.2% exposed to deltamethrin, and 16.5% exposed to permethrin, and 20.2% exposed to malathion, 5%, and 25 used as control. The 16-minute knockdown effect of pyrethroid resistance, I will show you in a table. This is all 100% of the tested for mosquito species show complete susceptibility to all 5 used insecticide diagnosis test. That is to say, the mortality after 24 hours was 100%. After 24 hours, and not the knockdown effect, which is measured at 16 minutes in all involved provinces. This is table, pyrethroid, deltamethrin, borkelimas 90%, and Culex bibinus 96%, Stephensii superpictus 100%. This is the knockdown percent. Permethrin, only the Culex bibinus is 71%. Lambda cyhalothrin, only Culex bibinus 92%. Organophosphate, malathion, it is the lower knockdown effect. 52 in borkelimas, 16 in superpictus, and 69 in Stephensii, and in Culex 38%. Carbamate, bendocarb, only in Stephensii it is 60%. This is the follow-up, every 10-minute follow-up until 16 minutes, as we mentioned in methodology. And you can see, this is for the deltamethrin, and each line represents a mosquito type. The blue one for borkelimas, the red one for superpictus, and the green for Stephensii, and the violet for Culex bibinus. This is deltamethrin, 0.05%, and this is the knockdown percent. Lambda, the same graph for lambda cyhalothrin. This is a graph for permethrin, and this is a graph for malathion, as I mentioned before. It is with the lowest knockdown effect among the tested insecticide. Conclusion, the national Iraqi insecticide resistance management was successful. Continuous monitoring for insecticide susceptibility are highly recommended for ED resistance detection. The national Iraqi insecticide resistance management depends on restriction of spray. We not spray haphazardly, only the affected area and in typical time when the density of the vector is high. And this is one of the methods for management of resistance. So you restrict the use of insecticide. Also, we depend on rotation of insecticide. Between 2 years we use VCAM, and then we use deltamethrin. Okay? So, fortunately, till now, we have no resistance, but organophosphorus should be monitored closely. Thank you. Any questions? Any question? Yes.
Thank you very much for the presentation. How can we data about the usage insecticide in the health sector
Yes.
Have you any plan for vector control in the leishmaniasis?
Yes.
Or just you are doing rodent control?
No. As you know, leishmaniasis is transmitted by the sandfly. The same insecticide works on the mosquito and also